Hi, this lesson is about operations on functions and composite functions. But before we practice doing operations on functions, let's remind ourselves about some rules on how to manipulate monomials. So those are the 6 rules here on the left. The first one says that x to the 0 power is 1. In fact, anything to the 0 power is 1. So it could be 5 to the 0 power is 1, or negative 124xyz to the 0 power is also 1. So it could be something very simple or something more complex. The second rule says that x to the m times x to the n. When you multiply exponential expressions with the same base, x being the base in this rule, then you add the exponents. Rule number 3 says that if you have x to the m raised to the nth power, that in that case you multiply your exponents. And then the fourth one is that if you're dividing where you have x to the m over x to the n, you simplify that by subtracting the exponents, the one in the numerator minus the one in the denominator. And rule number 5 and 6 are similar, and we need those rules because you shouldn't leave negative exponents in your final answer. So if you have x to the nth power, you correct for that by taking the reciprocal of x and raising it to the positive n power. So x to the negative n is the same as 1 over x to the n. And then the 6th rule is the opposite. If you have a negative exponent in the denominator, you correct for that by bringing the base up to the numerator and changing the exponent to positive. So 1 over x to the negative n is x to the positive n power. All right, so let's do some operations. In example 1, you're given 2 functions, f of x and g of x, and we are going to add them, we're going to subtract them, we're going to multiply them, and we are going to divide them. All right, so f of x is a binomial, 2x to the 4th minus 6x, and g of x is a monomial, that's just 2x. So first one is f of x plus g of x. So here are the 2 functions that we're adding. When you're adding functions, you need to combine like terms. And so like terms are the terms with the same variable part, or basically just 2 constants. So here we're going to be able to combine the minus 6x and the positive 2x. The 2x cubed doesn't change, 2x to the 4th doesn't change. So when you add them, you get 2x to the 4th minus 4x. So you combine the coefficients. Negative 6 and 2 gives you the minus 4, and the variable part stays the same. When we're subtracting, it's the same idea. We have to combine like terms. So here the negative 6x and the minus 2x will combine to give you the minus 8x, and 2x to the 4th does not change. So your answer is just 2x to the 4th minus 8x. If I had done it in the opposite order, like I did here on the right, if I did g of x minus f of x, well, there we would have had to do a little bit more work because the minus would have to get distributed across these 2 terms in f of x, because that's a binomial. So when you do, that's what you get here, 2x minus 2x to the 4th plus 6x. And then you would follow the same rule that you did in the previous 2 examples, is combine the like terms 2x and 6x, and the negative 2x to the 4th does not change. So you get that answer on the right, negative 2x to the 4th plus 8x as your final answer. In the next example, we're multiplying. So we have f of x times g of x. So we are multiplying a binomial times a monomial. So you need to distribute. And when you distribute, you need to use the second rule that we talked about above, this one here, which says add your exponents. So when I multiply 2x to the 4th times 2x, you get 4x to the 5th power, because this exponent is 1, and 4 plus 1 gives me the 5. And the same thing when you distribute to the minus 6x, well, 2x and negative 6x will give me negative or minus 12x to the 2nd power. Now we're on our division, and when we're dividing, we're going to be using rule number 4, which says to subtract the exponents. But before I do that subtraction, I show you here that I am separating each term in the numerator and dividing it by the monomial 2x. So I have 2x to the fourth over 2x minus 6x over 2x. So the first term, 2x to the fourth over 2x, well, the 2's cancel. And x to the fourth over x leaves me with x cubed when you subtract the exponents. And with the second term, the x's cancel, and 6 divided by 2 leaves me with minus 3. All right, so now let's talk about composite functions. A composite function is a function of a function. So it's a function within a function. So notation, common notation that's used is either this one, and that's read as f of g of x, or this is also common notation. This is also read as f of g of x. I tend to use the first one more, but you might see the second one in homework or in books or other lessons that you might look at. So when you're considering composite functions, you have to understand which one is the outer function, which one is the inner function. So if it's written like either of these two ways, you would consider f to be the outer function and g to be the inner function. If you wrote it in the opposite order, like I did here on the right, g of f of x, then g would be considered the outer function and f would be the inner function. All right, so let's identify outer and inner functions in the following composite functions. So we have a is x squared minus 5 to the third power. So the outer function is the cubed part. That's what you see here. And the inner function is the x squared minus 5. So let's move on to the next one. What's the outer and inner function in the square root of 2x cubed plus 4x? Well, the outer function is the square root, and the inner function is the binomial on the inside, 2x cubed plus 4x. Then let's move on to the third one, which is x squared plus 2x minus 1 to the negative 4. The outer function is to the negative 4 power. The inner function is the trinomial x squared plus 2x minus 1. So then I put here D. This might look a little foreign for now because we haven't talked about exponential functions. But if I have y equals e to the 2x, where e is your base and 2x is the exponent, your inner function would be 2x and your outer function would be e. So just a quick rule of thumb to figure out outer and inner is whatever you would evaluate first in terms of order of operations, that would be your inner function, and whatever you would evaluate last, that would be your outer function. So in other words, if I were to plug in, let's say, I would say let x equal negative 3. Well, first you would multiply 2 times negative 3. So that's your inner function, the 2x. And then that result, which is negative 6, you would then raise that e to the negative 6 power. So that would be your outer function. And the same would be true in any of these, right? If I were to evaluate this at x equal to 0, first I would plug in the 0 squared and subtract 5. So that's my inner function. And then that result, which would be negative 5, would be cubed. So that's your outer. So that's one way to figure it out. And understanding outer and inner functions is important, not only for this course and to be able to identify attributes and evaluate functions, composite functions, but it's also important later on when you take a calculus course. All right, so let's evaluate this with some numbers. Suppose I want to evaluate f of g of 2 and then evaluate g of f of 2, given that f of x is negative 3x and g of x is x squared. So this means that I have to evaluate g of 2 first, and then whatever answer I get there will get plugged into my f of x function. So f of g of 2 would mean that I would substitute 2 in here. So that would be 2 squared. And that then would be f of 4. But then that means you plug in 4 in here and what f of x is defined to be. So then that would be negative 3 times 4. And that would give me an answer of negative 12. Now we're going to do this in the other order, g of f of 2. That means you have to plug in 2 in for f of x. So I would have g of negative 3 times 2. And that would give me g of negative 6. But then that means you have to plug in negative 6 in for what g is equal to, and g is x squared. So this is negative 6 squared, and that would give me an answer of 36. Okay, so let's practice other functions, other types of functions. And this is going to be a little bit more abstract because we don't have numbers. But suppose you were asked to find the composite function g of f of x, given that f of x is 2 root x, and g of x is negative x to the fourth plus 3x squared. So that means that I have to plug in 2 root x into this function. So everywhere there's an x, it has to get replaced with 2 root x. So that's exactly what you see here. I have negative, instead of negative x to the fourth, I'm going to have negative 2 root x to the fourth power. So that's replacing this with 2 root x. And then plus 3, and then replace the x squared with 2 root x. So then the rest of the work you have to do is just to simplify those expressions. So 2 root x to the fourth power, that means you have to multiply this 4 times. So 2 to the fourth is 16, and root x to the fourth power, that means that you have root x times root x times root x times root x, which is basically just x squared, which is what you see here. So we have the negative 16x to the fourth, and then we have to square the 2 root x, and so that becomes 4x, and 4x times 3 is the 12x that you see below. Okay, so let's move on to the next example. And here I have the cube root of r. F of r is the cube root of r, and r of x is x cubed. So notice that there's different variables here, but that's still okay. And we want to find f of r. So that's just different notation to ask you to find the composite. So f of r means that you're going to substitute r, which is x cubed, into where the variable is. So this becomes the cube root of x cubed, but this is something you can simplify. The cube root of x cubed is just x. Okay, and that will mean something important when your final answer, when you evaluate a composite, is x, and that's something that we'll talk about in the next section. So here's a couple of more examples. Suppose I have f of x equal to the square root of x squared plus 1, and g of x is 3x minus 1. And suppose you're asked to find f of g of x. So f of g of x, that means that g of x is the input for f. So g of x is 3x minus 1, and now 3x minus 1 has to get substituted in here where your x is, because f of x is the square root of x squared plus 1. So that's the work you see here. I have the square root of, and instead of x squared, you write 3x minus 1 squared, and then plus 1. Then when you FOIL this out, so you expand this, you get 9x squared minus 6x plus 1, and then that plus 1 has to get combined with that one. So in the next step, you combine like terms, and you get the square root of 9x squared minus 6x plus 2. Okay, Let's do another one with e since we talked about it before. So we have f of t equal to e to the t and g of t equal to 2 root t. And we're going to find two different composites, f of g of t and g of f of t. So remember, the inner function is what gets plugged into the outer function. So here, f of g of t, that means you're going to plug in 2 root t into f of t. And so 2 root t is going to replace your variable here. So f of 2 root t is e 2 root t. And you really can't simplify anything else, so you're done with that one. Now we have to evaluate g of f of t. And that means that f of t is the input into g. So this will be g of e to the t. So that means e to the t will replace the variable in g. So you get 2 square root of e to the t power. Okay, and then one last thing is that it is possible to have more than 2 layers of a composite function. So instead of just f of g of x, suppose I had f of g of h of x. So in this case, there's 3, where h of x is the innermost function, g would be your middle function, and then f would be your outer function. So it is possible for that to happen. So an example of that would be something like, let's say I say y equals e to the square root of x squared plus 1. So x squared plus 1 would be the inner, the square root function would be the middle, and e would be the outermost function. Okay, but for the most part, you'll just be dealing with 2, an outer and an inner, but it is possible to have multiple, even more than 3. All right, so that's it for this lesson. Give the homework a try. Good luck.